Hello everyone, so now let's do one more lab. If you remember, in our Cisco Packet Tracer series, we learn how we can configure the ACL. Now we have the idea about the ACL. Now what we will do one lab for the NAT also. After that, we will move for the small organization network. Then we will go for the big organization network. Okay. So let me do here. I will design the topology from the scratch. If you see, this is my one router R1 and this is a router R2. And let me take one more router. Imagine this is a ISP. Okay, this is a ISP. And we can say this is a R1 and this is a R2. And we will take some switch. I will take one switch here, one switch here. And we will take some machines like our PC. One PC or 3 PC here, 3 PC here. Now we will do the connectivity. If you see, these two routers are connected here, and I will connect these to switch, and these PCs are connected to the switch. Okay, let me connect here, and same thing here also we will connect. And from here to here we will connect this one. We don't have the port, so we need to add the port. If you see, I will switch off this router and I will go here. I will put this port, this one or this one. I will put anything. Let me see which one I can take. This one let me take, and I will power on the router. Now let me connect. This is the port. Okay, imagine this is our router, and this is the PC1, PC2, PC3. We will assign the IP here to the machine. Let me move like this. Okay, so this is the ISP. If you want, you can change the icon also. We can search the icon and assign here the icon. So what I will do, let me write the IP schema. Here we are going to use, let me write 1.1.1.1, and here will be 1.1.1.1.2, and this side will be our LAN network 192.168.1.1, and this side will be 192.168.2.1, and here ISP give the IP, imagine 200.1.1.1, and ISP router is having the 200.1.1.2. Okay, so this is a scenario. We are going to do the lab for this one. This is your two router, this is the IP, and this IP ISP give you, this is ISP router IP, this is your router IP, and here we will have the IP. Let me put the label here 192.168.1.2, and let me assign this to the machine. I will go here, I will assign here, and gateway will be 192.168.1.1. okay, and then we will assign here also 1.3, and then we will go here also in the desktop, assign here gateway will be 1.1, here also same thing 1.4. let me copy and go here in the desktop, assign here gateway will be 1.1. just I assign the IP address to the machine. This side will be 2.2 because here we have the network 2. If you see this one, so this side we will put 2.2 and the gateway is 2.1. Here 2.3, and the gateway will be here, gateway will be 2.1, and here last PC 2.4, and I will copy and let me paste here. If you see here, this will be 2.1. Now we will start our configuration. Okay, now we will start our configuration. First of all, I will assign this IP, whatever IP we have. So let me do, we will see. I will go in the CLI of the router. Now I am going to configure this IP, this IP. If you see, I cannot see the port, so I will go here in option preference and I will enable always show the port. So now I have the port. So what I will do, I will go to this port, I will assign this IP. Okay, so let me do now. What I will do, I will write here no, then enable config T, host name R1, then interface fast Ethernet 0 by 0. I will write the IP address 1.1.1.1 255.0.0.0 no shut. Okay, and then other interface fast Ethernet F0 by 1, IP address 192.168.1.1 space 255.255.255.0, and we write no shut. Just I assign the IP. Okay, if you want I will show you. This already we learn how we can assign the IP. Okay, so I assign the IP. If you want I will enable the OSPF also, because we need to run the route here. If you see, this network will communicate with this one, this side also. So this route, whatever this IP, this router should learn, and this router also going to learn this IP network. So for that purpose, what we need to do, we need to do the any routing protocol. So I am going to use the dynamic routing protocol. I will do the OSPF. Okay, so let me configure the OSPF here. How we will configure the OSPF? We will write router OSPF 1. Okay, then I will go on under this interface fast Ethernet 0 by 0 IP OSPF 1 area 0. Then other interface, this is the fast Ethernet 0 by 1. I will write fast Ethernet 0 by 1 IP OSPF 1 area 0. So I enable the OSPF also. Now I will save the configuration. R1 is finished. Now let's go for R2. So in the R2, if you see what interface we have, if you see here, let me show you. Enable, first of all let me do the basic setup. Host name is R2, and now interface fast Ethernet 0 by 0. This one I am doing fast Ethernet 0 by 0. What IP we are going to assign here? This one. Okay, this IP 1.1.1. I will make little zoom in. Now you can see. Okay, I hope you can see now. This IP we need to assign. So what I will do here, I will write IP address 1.1.1.2 255.0.0.0 no shut, and then we will write interface fast Ethernet 0 by 1 IP address 192.168.2.1 255.255.255.0, and I will write no shut. This one. Now we need to do this also. Here we have the Ethernet. Whatever interface we have, we will configure, no problem. So I will write interface ETH1/0, and then I will assign IP address 200.1.1.1 255.255.255.0, and I will write no shut. Okay, and we need to configure one default route. So I will write default route, because whatever traffic we are getting, we need to forward that traffic towards the ISP. So this is ISP IP 200.1.1.1 is the ISP IP, or yeah, this is the ISP IP. So we need to forward the default route towards the ISP. So how we will forward? Let me write here. I will write IP route 0.0.0 and then 0.0.0. After that we will write 200.1.1.2 200.1.1.2. okay, this is a default route. If you want, I will show you. Show IP route. We have the default route. Now we don't have. Where we configure just now? Let me check. Did we configure? Let me check. Show IP interface brief. Yeah, here this is the IP. Okay, and here, and let me write here show IP route, show run, because that interface is done, that's why we cannot see. But let me check here. Configuration we can see. Yeah, this is a default route is there, but this interface is not up, that's why it is not showing. But our configuration is finished here, so I will save the configuration. After that I will go here. In the real scenario we will not touch the ISP router. Here we will do, but in the real scenario we will not touch the ISP router. Okay, I will just rename as ISP, and we will see what interface I have. Do show IP interface brief, fast Ethernet 0 by 0. If you see, this is the interface fast Ethernet 0 by 0. we need to assign this IP. So I will go interface fast Ethernet 0 by 0. I will write here IP address 200.1.1.2 255.255.255.0. I will write no shut here. Okay, now this interface go up. And if you want to create any loopback here, we can create any loopback saying that this is a Google server, like interface loopback 0, and I will write IP address 8.8.8.8 255.0.0.0. Okay, imagine that is a Google for our lab purpose. Okay, now if you want to check, you will have the static route also. If you see show IP route, it came here now. But now, and here we did not configure the OSPF, so let me write here. I will go router OSPF1 interface fast Ethernet 0 by 0. Which interface I am doing for this interface? Fast Ethernet 0 by 0 and fast Ethernet 0 by 1. I will not do for this one. This is going to the ISP side, so we will not enable any routing protocol for the ISP side. Okay, other side we will not do. So what I will do now, enable only in this interface and this interface. So let me do now here IP OSPF1 area 0, other interface is fast Ethernet 0 by 1, IP OSPF1 area 0. Okay, I enable. If you see show IP route, we will have the route show IP route OSPF. We are getting this route. Okay, 192.168.1.0 we are getting from the OSPF. So what we can do, we can now our lab is mostly cover, only something is pending. I will show you what is pending. First of all, let me check here. I can communicate with this PC to this PC or not. Imagine I am sitting here, I want to communicate with this machine. Let's see, ping 192.168.2.2. I am pinging from here to this machine. Okay, first packet will drop for ARP. It is working, it is coming here till here. This communication is working from here to here. Okay, communication is working from this side to this side. But if you ping this IP or the loopback which we created here 8.8.8.8, it will not work, because we need to enable the NAT here or PAT, port address translation, because this is the private IP. Whatever private IP we are going to use here, this site in the real scenario we will have the public IP here. So when we want to make the communication, when we want to access the internet, we should have the public IP. Okay, here in our LAN network we will have the private IP. So this private IP need to translate to public IP in the real scenario. So what we will do, we will configure the PAT NAT. We are saying that is a port address translation. If we did not configure, it will not work. Let me show you. I will ping 200.1.1.2. okay, it will not work. See, destination host unreachable. I am pinging this IP. Or if I want to ping the Google also, imagine Google we are saying 8.8.8, it will not work. See, it is not working. So what we can do, we need to configure the NAT. Before going that, let me reduce the font size, because it is difficult. We cannot reduce the window size. So now let me try. I think now we can reduce. This is very small. Let me increase the font size again. This is 13 is good. Okay, let me keep like this way only. Anyhow, now if you see, everything is okay, but this PC or this PC cannot communicate to our loopback. That is the 8.8.8, the Google IP. We cannot access the internet. This is the ISP. We cannot access any internet here from this site or from this site. So we need to enable the NAT here. So that is our topic. We are going to learn how we can configure the NAT. Okay. So to do the configuration, first of all, we need to select the traffic. So how we will select? We will select the traffic from ACL. Then we are going to apply the NAT. So we are going to learn that one now. Let's do the NAT. So what we will do? We will do NAT here. Okay. So I will go to this router R2. First we need to select the traffic. So I will use access list. I will use number 1 permit and network which we want to permit 192.168.1.0. This network 1.1, that is 1.0, and I will write the wildcard mask 0.0.0.255. Okay, this one I selected, this network 0.0.0.255. So this one I am selecting. Okay, this one I am selecting, then I will select this one because we have only these two. So first I am selecting this one, and then again I will select access list 1 permit 192.168.2.0 0.0.0.255. Okay, then we need to do IP NAT, and then inside source list, what is the list number? We put 1 here. If you see this one 1, and then interface, which interface we need to do that one? This interface ETH 1/0. So I will write ETH 1/0, and then we will write overload. Don't forget to write this one. Okay, and after that what we will do? We will write IP NAT outside and inside. So first of all, what we done? We apply NAT to this router, the router which is connecting to the ISP. After that, this interface, in this interface we need to say that one IP NAT inside source list 1 interface. This is the interface which is connected to ISP. We will write overload because we are doing the pad. And after that we need to go to this under this interface, and we need to define IP NAT outside and go under this interface, and this interface say IP NAT inside. Okay, so let's do that one. So I will go here in this interface. If I can reduce the size, so we can do, let me do this way. I will write here interface ETH 1/0 IP NAT outside. Okay, and then interface fast Ethernet 0/0 IP NAT inside, and I have one more interface fast Ethernet 0/1 IP NAT inside, because this is the inside, right? Now I done. So let's see now it will work or not. So I will go here. Before it is not reachable. Let's see now, because it is translating the IP. So we will see. Still I have some issue. Let me check what issue we have. I can ping this IP. Destination host unreachable still. Okay, let's see. Request timeout destination. So maybe something wrong we done here. Let's see our NAT configuration. We select this traffic access list 1 permit, and this is a network, another network, and then we write IP NAT inside source list interface. Okay, let me check here. This is the interface which is connecting. Okay, and we told overload, and then we apply this interface as a output IP NAT outside, and this is a IP NAT inside. So let me check. Show IP NAT translate. It is not translating anything. Let me see one more thing. This PC can go or not, we will check, because here maybe we don't have default route, so here we will not go, but let me check from this side. Okay, so let me ping here, ping 8.8.8.8. okay, let's see now it will work or not. Depending upon this one, we will do one more thing. Yeah, if you see what is the issue, if you observe here, when I am sending the request from here to here this way, it is not working. But when I am sending from here, from this side to this, it is working, because here in this router we have the default route. Here we don't have the default route. When we are requesting 8.8.8, he is checking his routing table. That 8.8.8 entry is not present in this router, so he is dropping that traffic. So what we can do, we can configure default route towards to this interface, or there is one more method we can do that one also. If you remember, we have default route here, right? So in the OSPF we can go and we can create the default route. I hope you remember in our CCNA series we done that one also. But anyhow, if you are confused, let me show you. What I want to say that whenever you want to send the traffic, whenever you want to send traffic from here to the internet, you should have the default route in this router also. Because if you are pinging facebook.com, this router don't know, he will drop that one. You are pinging youtube.com, this router don't know, he will drop that one. So we need to put one default route saying that if you cannot find in your routing table, forward the traffic here. And this router already having the default route, he will forward the traffic to the ISP. So no problem. But here we created default route from here to here, but here we don't have. So manually we can create, or another method is we can go inside the OSPF and we can say default information originate. When we told default information originate, OSPF is going to send the default route. So these two methods are there. We can use any one method. So let's do here. Let me try here. I will write router OSPF1, router OSPF1, and then I will write default information originate. So what, with the help of this one, OSPF is going to send the route, default route here. We will have after some time default route here from the OSPF. If you want, we can check show IP route, and if you see, this is a default route we get from the OSPF. Now it will work. Okay, let's try now. Before it is not working, now it will work. See, it is working. We are able to ping the ISP IP. Now let's try. I can access the google.com. This is a google.com. We are imagining 8.8.8 is a Google server. It is present here in the ISP, and I am able to communicate with the Google server. Okay. So the concept is here. What I want to explain you, if you see, this is our company network from here to here. This is our company network. Here generally we are using the private IP, and ISP we taken the ISP connection, only one ISP we taken. Our company is a small organization. Imagine your company is a small organization, you have only one ISP. They terminate the fiber here in the switch. Generally we have the switch in the real scenario or the mux demux. So they terminate here. From there you connected to the router. ISP told you configure this IP to your interface and point out the default route towards this IP. So you done that one. After that, you configure, you have one more router. So you have network, whatever network you are using, you enable the OSPF, any routing protocol. So your route, this will come here and this route will go there. And then you realize you need to configure NAT, because NAT is going to translate the private IP to public IP, because your client cannot access internet with the public IP, private IP. So they are using the private IP, so you configure the NAT. When you configure the NAT, it start, these guys are able to access the internet because this IP is translating from the private to public. But these guys are unable to access the internet. Why? Because we don't have any default route here in this router. We need one default route pointing towards here. If anything, example, this guy want to go to youtube.com. We don't have any entry about the youtube.com in our organization router. So we need to forward this to this router, and this router need to forward to ISP. So what I can do, I can create manually the default route here like this, or I have one more option. If I go inside the OSPF and I write default information originate, because here we have the default route, so that route is going to forward in all the router by the OSPF. So I configure that one. So with the help of that one, our all PCs are communicating. So try to remember this concept. If you want, I will show you what I done. Just I go inside the OSPF, okay, and then I put default information originate. With this one, all the OSPF neighbor, whoever is running the OSPF, they are going to get the default route, okay, E2. This default route we get, and they are going to forward the traffic here. So this is a small scenario. In the coming classes, we are going to do one more lab, like a small organization. Then we will do little higher organization, like big network. I am just clearing your concept. When you have the basic understanding, good concept, then we can move for the big projects. Okay. Thank you. See you. Bye.